Hello, my name is Kevin, and I'm here to discuss modular programming in OCaml. So basically, the basic premise of modules is this idea that a single person, a single programmer cannot create a huge software system by themselves. They need many people. You need many people, many programmers to build this software system. But the question is, how is it possible to build this huge, cohesive software system with many people without there being tension and like miscommunication between programmers? That is where modules come in. Modules is basically a way for us to split up the components of our system so that programmers can work individually in modules, like programs to work on an individual module and then have that module communicate with other modules. Everything is very isolated, very encapsulated. So first, I'm going to demo a module called ListStack. I have it right here. And basically what modules do, basically what a module does is it allows you to define variables, functions, and types, basically anything you want inside of this module. And you can access the contents in that module by just doing the module name dot parentheses, whatever you want. So in this case, we could use modules to represent data structures like stacks. And then in this case, I made a module called ListStack, and it has a type called AlphaStack, which is an alpha list. I define a variable called empty, which is the empty list, and functions push, peek, and pop, which we all know. So with this module ListStack defined, let me show you how to define some values in it. So here's a perfect example. Okay, so I have ListStack in the namespace. So this is how you create a stack. So let S1 equal ListStack dots. So here, in order to use any value in ListStack, we need to first say ListStack, the name of the module, period, parentheses. And whatever goes into parentheses is what we want to access. So in this case, empty, that's a value declared in line 4. We have an alpha list that's empty. Now, also do now we have a list in list 5. So basically, with the module name, period, and the things we want to access in the module. So that's and then after that, let's do pop. Now we popped S1. We got the empty list. So that's a quick rundown of what modules are. They provide namespaces in which we could define types, functions, exceptions, whatever we want. And then we have other modules, and then we could import these modules into other modules and use the things we define in that module. So the next thing I want to discuss, and the final thing I want to discuss, is this thing called signatures. And basically, the basic idea with signatures, let's say we want our module to conform to a certain thing. We want our module to definitely have a certain variable or a certain function or a certain exception or a certain type. That's where signatures come into play. In a signature, we define things, we just specify things we want to put in that signature. It could be anything. It could be a function. And then we write a module, and then we say a module conforms to that signature if that module we define has everything defined in the signature in its own module. So that sounds a little confusing at first, but the basic idea is if we have a module ListStack, let's define a signature. Typically, you write the signature first, and then you write the module, but we'll do it vice versa. So In this case, the keyword is called module type. And then we call the signature name is stack L. We put the contents of the signature between sig and end. So in this case, I have the code right here. So we define a module type stack L, a signature stack L. Now, let's see. Does this list stack module conform to the stack L signature? Oops, it doesn't, because we have a signature mismatch, and the type alpha T is required but not provided. If you look, we define a type called alpha T, but we don't define a type called alpha T here. We call it stack. T is basically like an idiom in the sense where it's idiomatic for OCaml programmers to name the representation type of a module as T. So in this case, if we're defining a module called list stack, our representation type for this module is alpha stack. Idiomatically, we call this T. Now, every type variable and function that's in module stack L is in list stack. And now we don't have any type errors. So basically, this is very similar to Java's interface versus classes. The interface defines everything we want the module to have or the class to have. The class conforms to the interface if it defines everything in the interface. So yeah, that's the basic idea. I hope you enjoyed. I'm gonna say one last thing really quickly, but there's so much more to the modules. A huge topic in modular programming is the idea of functors, which is basically a function that takes in a module and outputs another module. That sounds really weird, but basically, really quickly, map is a module. A functor that's in the map module is called make. And whatever we put in parentheses, it must be a module. And the output of map.make parentheses, the module name, is a dictionary with the keys as the module inside of the parentheses. So if you have string here, there's a little area here. But basically, my bad. String map is a module. So this make is a functor in the map module. And I said functors take in a module and return another module. So in this case, map.makeString, that returns a module that basically defines a dictionary with string as the key for the dictionary. So that's just a little intro to functors. But yeah, that's it for modules, and I hope you enjoyed that little lecture.